Chapter 1 of Electric Circuit 2, First and Second Order Circuits. The difference between these two circuits are the components involved. In first order circuits, either the combination of RL, resistor inductor, or combination of RC, resistor capacitor. Whereas in second order circuits, three components combined together, resistor, inductor, and capacitor, in series, either in series or in parallel configurations. Next, under the subtopic of first order circuits, we have two main categories. One is source free, either RC or RL, and the second one is step response, RC and RL. The unit step function here is just showing the switching signal. Yeah, later on we will cover this one. So from these two categories of source free and step response, we need to understand first the source free, but we'll later explain in the slide after this. But here just to state the main difference. Source free. In the source free, at t more than 0, the voltage and the current source does not exist. Whereas in step response circuit, the voltage and the current source can be exist. Yeah. Source free, the voltage and current source cannot be exist. That's why it is called as source free. Whereas in step response, voltage and current source can be exist when t more and equal to 0. Okay, we go to the first subtopic, source free RC circuits. This is the basic figure of source free RC. If you can see here, there are only two components, R and C. If we take the nodal node here, we can see the current exit this node, IC and IR. If we form this into equation by using KCL, we know that the current exits the node must be 0. IR plus IC will be 0, since the two currents exiting the node. And then we can convert this IR and IC in term of V to the term of V over R, and here IC for the capacitor, C dV over dt. Why we need to convert from I to V? Because this is the derivation steps to get the value of voltage here, voltage which is referred to the voltage capacitor and voltage resistor. We are interested to find the V, that's why we convert the current here to the voltage. And continue the derivation step here. In this case, since capacitor is initially charged, we call it this one V0. This is actually t equal to 0, V0. We call this one as initial charge of voltage. Yeah, initial charge of voltage, which is t equal to 0. And the corresponding energy stored in the capacitor is half CV square. So this is the main formula for capacitor, so that when t equal to 0 is actually half CV here. Initial charge of the voltage 0 square. Okay, so this actually replace the initial voltage of capacitor. Again, by applying KCL node here, we know that the IC is actually C dV dt, IR V over R. Back to here, it's actually the same. This is just a derivation steps in order to get this final VT. Because to get this final VT from this equation, you need to rearrange rearrange the V here, and then how to diminish or how to remove these differentiation terms, integrates the two part here, and then you will get ln, and finally you will get this equation for RC circuits without the voltage source or current source. VT, V0, E negative T, RC. So V0 here again is the initial voltage of the capacitor, if the capacitor is first initially charged. From these equations, this is what we call natural response of the circuit RC. This is the explanation or the description of the natural response. Behavior, voltage and current of the circuit itself with no external source excitations. Yeah. So during T more than 0, there's no excitation here, no voltage or current source, and this is the natural response of the circuits. And it can be and the natural response is depicted in this graph. At T equal to 0, the voltage here is fully stored for the capacitor, the full value of voltage, which we can consider, or we can represent as 1 in terms of percentage here, or 1. And then the lowest value will be 0 here, and as T is increased, the voltage will be dropped. This is similar like the value of a battery. At first the battery is fully charged, and at certain time the battery will slowly discharge. Okay, so that's why a capacitor also can be the working function of capacitor can also be related to the battery. Okay, this graph exponent graph is actually consists of three types of RC, and RC. Here RC here is what we call tau, R multiplied by C, and based on this slope of exponential slope, bigger tau, the graph decays more slowly. Maybe the tau here the value of tau here is contributed by the value of R and C. So the bigger value of R and C, the slope here decays slowly compared to the value here, tau 0.5 will decay faster versus time, the value of voltage. Okay, back to here, and this is what I wrote just now. Tau equal to RC, VT V0 E negative T over RC. This is the main formula that for RC, the purple formula. And from here, from this graph also, we can calculate, or we can see here at T equal to tau, which is at T equal to R multiplied by C, the value of voltage, let's say this is 100%, the voltage here will be dropped to 36.8 voltage value when T equal to tau. Yeah, or if this is 1, the voltage will be dropped to 0.368 voltage when the T is equal to tau. What is tau? Tau equal to RC. From the basic RC circuit here, we know that the VC has same value with VR because the capacitor is parallel with the R, and we have obtained the VC, which is V0 E negative T over RC, so this will be same like VR. So in order to find the IR here, we can straightforward apply Ohm's law, I equal to V over R, but VR here replaced by V naught E negative T over tau. Tau stand for R multiplied by C, R multiplied C, and then over R. This is how the formula is derived. And also from this of the value of V and IR, we can calculate the power dissipated in the resistor. P equal to IRV. Okay, just replace V here with the V naught E negative T over RC and IR here with this one, and you can multiply this one and derive to obtain the formula for here. Okay, I think I don't need to show this one. Just replace this one. If you have time, try to replace this one, and finally you will get this formula for power. And then for the energy absorbed by the resistor up to time t, the symbol here W stands for work, but it is the same for the energy. So energy over time, so we integrate P over dt to find energy. It is the same formula, T from 0 to T, and we can use power here, V naught over R. This is basic formula for power. E negative 2T over tau, just V here, replaced by V naught E negative 2T over tau based on this one. And then if we do some integration here, we will get this formula, half CV squared 1 minus E negative 2T over tau. So this is the, you can try by yourself how to derive these ones, but this is just the formula, the straight formula that you can use if the question asks about power and work or energy. Okay, let's see example 1. Refer to the circuit below. Determine VC for the capacitor, Vx, I0, and I0 for t more n equals 0. Assume that Vc 0 is equal to 30 volt, meaning that the capacitor is initially charged at 30 volt. So here, since there is no voltage source, the capacitor here works as a voltage source that supply or operate this circuit. Okay, now try to change the circuits into the main figure or basic figure of RC. If you can draw like this one, this is R and this is C. Okay, maybe we can try 12 parallel with 6 and plus 8. We will get the R equivalent, and we can use this formula V naught E negative T over RC in order to get the VR and also VC here. So V naught is equal to 30 and E negative T RC. R here is the R equivalent, 12 parallel with the C plus ohm, and C here multiply with the 1 over 3, we'll get the final value, which we'll describe in the next slide. But this is how we're gonna do for in order to find the VC and Vx here. But in order to complete the Vx, we need to use voltage divider. This slide shows the step-by-step solution of the example 1. Okay, at first, transform the circuits into basic of RC, which is make it parallel of 12 and 6 plus the 8 ohm here, like this one. So, and the final R equivalent is 12 ohm. multiply the R equivalent with the value of capacitor here, 12 multiplied by 1/3, and I will get 4 seconds for the tau. Insert back the value of V0 and tau into this main formula, and straightforward you can get the value of VC is equal to 30 e negative t over 4 voltage. Okay, next we continue with finding the Vx here. So Vx here you need to do voltage divider, you need to use voltage divider, but first before applying voltage divider, parallel 12 with the 6 here, parallel 12 with the 6 you will get 4 ohm. This is the calculation of parallel 12 and 6, and like that ohm. We are interested to find here Vx, but we know that 12 and 6, V6 and V12 will be same value. That's why we make it parallel, then calculate the Vx. And from here, just use voltage divider. 4/4 plus 8 ohm times with the VC. VC is from the previous slide. We have calculated VC from the previous slide. And then here, straightforward, you can, after use voltage divider, you can get 10 e negative t over 4 voltage for the Vx. Finally, we will focus on how to find I0. Okay, if you can see from here, this is polarity of Vx and this is polarity for Vc. Yeah, I0 is referring to this one, and this is I6 and this is I12. So if you take this as a node, I12 current exit the node plus current exit the node I6 plus I0, current exit the node here will be 0. So your job or your task is to find I0. In order to find the I0, you need to find I12 and I6 first, because I12 plus I6 will get negative I0. Okay, so if this is the same, just I put negative at I0, but this one put negative at I12 and I6. So I12 here is just straightforward. Vx you already obtained, Vx over 6 ohm, and then this one also Vx over 12. Vx you have found, you have calculated this one. So straightforward. Once you get Vx over 12 and Vx over 6 plus the value, this one V12 10 and V6, sorry, I12 is this one and I6 is this one, plus, and then you will get I0, which is negative 2.5 e negative t over 4 ampere. This I0 has the same value as IC that flows through the capacitor. I0 is equal to IC. So in order to find the IC, we can straightforward use the value of I0, which is negative 2.5 e negative t over 4 ampere, because this is the same. Or we can use this formula. We know that the capacitor has formula of I equal to C dV over dt. So differentiate first the voltage for this circuit, which is 30 e negative t over 4. How to differentiate this one? dt, how to differentiate this one? Bring the coefficients of t, which is 30, write this one first, bring the coefficients, then write by e negative t over 4. That's why you will get 30 over 4 here, e negative t over 4. This is the same like this one. And then once you successfully do the differentiation of this dvc of dt, multiply it with C, continue multiply it with C, capacitor, and finally we get the same answer, which is negative 2.5 e negative t over 4. Now we look at example 2. The switch in circuit below is open at t equal to 0. Find Vt for t more n equal to 0. Vt here is referring to the capacitor. So we still use the same formula, which is Vt equal to V naught E negative T over Rc. Okay, but in this circuits, you need to analyze the circuit based on two conditions, which is the first condition is t less than 0 to find V naught. What is the V naught here? So draw the circuits when t less than 0. So t less than 0, the switch is switched on and the circuit is connected. So the voltage here, this looks like an open circuit. The voltage here will be same like V12 and V4, but in order to find the V here, you need to make it parallel 12 and 4 first. Yeah, so it becomes 12 parallel with the 4. There's only one resistor here, so you can use voltage divider, find the voltage here, and then you get this V here seems like V capacitor. Okay, this is the summarization for the next slide, but here I just drafting the solutions here. So settle for this one and analyze the circuit when t more than 0. So t more than 0, what you need to do is to disconnect this line, because according to this statement, the switch is switched off when t more than 0. So at these conditions, the capacitor here will supply the voltage, and in here you are required to find the R equivalent, yeah, because you need to find the tau. R equivalent here is equal to 12 and 4. 12 and 4 parallel. You have counted this one previously, maybe here during your operations to find the V naught. So after you find the R equivalent, you can just multiply it with this one. You get the value. Okay, this is the detailed descriptions about how to analyze the circuits. Here you can see the same step like what I've explained. This one just a longer statement, but t less than 0, find the V naught here, which is 8 volts. This is how the circuit is transformed. Next, after t more than 0, you need to find the R equivalent, and from the R equivalent you can multiply with C, you will get the tau and directly insert back to these equations.